These are questions that have probably been with us since the beginning of our existence. How did the universe come into being? What came before? And are we really alone? The James Webb Telescope was supposed to help us find the answers to these fundamental questions. However, the most powerful space telescope ever built is not only providing us with the insights we hoped for, but is also turning virtually everything we thought we knew about the evolution of the cosmos on its head. Webb has revealed a series of enormous structures in the depths of space that astronomers describe as simply impossible. But how do we deal with a discovery that, according to our model, should not exist at all? Are our established theories still valid if we find something that completely contradicts current cosmology? Or to put it another way, could it be that the universe did not begin with a Big Bang after all? Stay tuned until the end, and join us as we get to the bottom of this gripping space mystery. Whether we're interested in space exploration or not, everyone has probably heard about the technological marvel known as Webb that is currently in operation out there. With its 6.5 m diameter telescope mirror and 4 infrared instruments, James Webb is the largest and most powerful space observatory in history. And in some cases, it's 100 times more sensitive to electromagnetic waves than its scientific predecessor Hubble. Developed specifically for infrared astronomy, Webb is set to take our understanding of the structure-forming processes in the universe to a whole new level. It will also investigate the formation and evolution of galaxies, black holes, and stars, as well as examine exoplanets for their potential habitability. In addition, Webb will also observe the first luminous objects in galaxies that formed after Big Bang and the subsequent dark age 13.5 billion years ago. But what use are the most elaborate theories and comprehensive models if the cosmic reality ultimately turns out to be completely different when a Webb discovery is so surprising and confusing that it plunges the entire scientific community into a deep crisis and forces scientists to make the following statement: we have discovered the impossible. To err is human. A brief look at our own past proves this. Our ancestors were firmly convinced that the Earth was the center of the universe around which all other celestial bodies revolved. Even Einstein believed so strongly that the cosmos was a static and unchanging construct that he added the cosmological constant to his field equations. Today, however, we know that our home planet is just a tiny piece of a gigantic, possibly infinite structure that we are still far from understanding. And after Einstein also realized that the universe has been expanding continuously since time immemorial, he described his constant as the biggest blunder of his life. And yet, despite all the failures to date, there are things that are literally set in stone. The overwhelming majority of astronomers agree that the universe came into being 13.8 billion years ago in the much-cited Big Bang. Contrary to the official description, however, this process does not describe a violent explosion into an existing space, but rather the rapid birth of space itself from an original singularity. Matter and time also emerged from this tiny hot starting point. But how can we possibly know that today? Well, quite simply by looking back at the development that Einstein initially denied so vehemently, namely the expansion of the universe. In doing so, it's possible to calculate back to the cosmic starting point, or more precisely to a point at which the density of matter and energy is infinite and all spatial distances are zero. However, it should be noted at this point that the various Big Bang theories do not deal with the actual birth of the universe, but with the early universe immediately after its creation. The detection of cosmic microwave background radiation is considered outstanding evidence for the Big Bang theory. This nearly isotropic relic dates back to a time when the universe was only 380,000 years old and still fills the entire universe today. But when it comes to the structures that formed shortly after the Big Bang, one of our fundamental assumptions is that the first galaxies should have been small. According to the astronomical consensus, the first stars existed just 200 to 300 million years after the birth of the universe. However, when the first galaxies developed from these stars and how quickly they grew is still an unsolved mystery. The only thing that is certain is that experts have identified several galaxies in the images taken by the James Webb Telescope that existed just 300 million years after the Big Bang. And as expected, spectral analyses reveal that these galactic premature babies were quite small and low in mass. However, the 6 early galaxies identified shortly afterwards through the previous model into complete chaos. Although they are of a similar age, they are almost as massive as our Milky Way is today. Astrophysicist Evo Lab, who was part of the research team that analyzed the images of the galaxies, described this initial reaction to the groundbreaking discovery as follows. I ran the analysis software and it spat out 2 numbers. Distance, 13.1 billion light-years. Mass, 100 billion stars. I almost spat out my coffee. I knew we had just discovered the impossible, impossibly early, impossibly massive galaxies. Why these galaxies shouldn't exist at all. Together with his team at Swinburne University of Technology in Melbourne, Lab analyzed several images taken by the NACAM near-infrared camera from the James Webb Telescope's early release program. The images show a section of the sky near the Big Dipper, which had already been studied by the Hubble Space Telescope and is commonly considered part of the dawn of the universe. During their detailed analysis, the experts noticed a series of striking reddish-shimmering points of light whose characteristics indicated a great distance and consequently a great age. Using redshift, the researchers concluded that the light had taken more than 13 billion years to reach our eyes on Earth and that it therefore originated from objects that existed just 500 to 700 million years after the Big Bang. The other characteristics of the points of light indicated that we were dealing with 6 very early galaxies. But instead of the predicted baby galaxies, the scientists were confronted with fully grown galactic giants that exceeded all expectations. The dataset revealed that all 6 early galaxies have more than 10 billion solar masses of stars, and that one of them could even be approaching the 100 billion solar mass mark. Joel Lee from Pennsylvania State University, who was also part of the research group, simply could not explain the strange circumstance, which is why he initially suspected that he had made a mistake. However, this suspicion was not confirmed. The experts had not made any mistakes, and the mystery remained. The researchers' small remaining hope was based on the fact that, contrary to the data collected, the structures are not actually galaxies. This means that they could at least partially be dust-shrouded black holes. But even this would mean that there was far more stellar matter in the early cosmos than previously assumed. Either way, Webb's discovery stands in stark contrast to nearly all generally accepted cosmological models. And for one very simple reason. According to our current knowledge, there simply wasn't enough normal matter at that time to form so many stars in such a short period of time. Erica Nelson, co-author of the study, is quoted as saying, "Even if only one of these galaxies is real, it pushes our understanding of cosmology to its limits." The universe breakers were just the beginning. To explain the existence of galaxies, either the density of matter in the early cosmos must have been 2 to 5 times greater than our models suggest, or galaxies must have formed in a way that is completely unknown to us. The bottom line is that scientists have been in a real pickle ever since. Both cases require profound change in our understanding of cosmic evolution. In light of this, it's hardly surprising that these mysterious structures have become known as universe breakers. After all, the discovery calls into question what was previously considered scientifically proven. It appears that the mass of stars in this early phase of the cosmos was up to 100 times greater than the old model suggests. Until now, cosmology has assumed that galaxies begin as small clouds of stars and dust and gradually grow larger. But could this be the only way galaxies form? American astrophysicist John Cromwell Mather, who has spent his entire professional life working at NASA, also has no choice but to admit that he and his colleagues have reached a dead end. He says, "People want to know what's new. What have you found out?" And the answer is that the first galaxies grew differently than we expected, and we don't know why all the predictions were wrong. And while this discovery is a real problem for science, according to Leah, we should not forget that this was only the beginning of an extremely confusing astronomical journey. Since then, Webb has added many more objects to the star maps that, according to our understanding, should not exist at all. These include in particular other early galaxies that are astonishingly advanced not only in terms of their mass but also in their shapes. In addition, there are indications of individual galaxies with extremely high redshifts that may have formed when the universe itself was still shrouded in darkness. In some cases, unexpectedly mature chemical elements were also found, suggesting that several generations of stars must have been active very early on. Finally, Webb also provided puzzling insights into the so-called reionization epoch. In some galaxies, the expected signatures of neutral hydrogen are missing, suggesting a much faster transition from a dark to a light-filled universe. In conclusion, it can be said that the James Webb Telescope is already fulfilling its overarching goal with flying colors. It is undisputed that it has revolutionized our cosmological view of the world. All the findings to date clearly indicate that the formation of galaxies, stars, and structures in the cosmos took place much earlier, faster, and possibly in a completely different way than we previously thought. And who knows what other wonders Webb will bring to light in the future. And now, we would love for you to click the thumbs up and subscribe to never miss another video from us. We'll see you soon.